What's up, ladies and gentlemen, it's your boy P Sizzle here, back at it again with another math stat tutorial. Today we're going to be looking at exercise 8.86 in our second favorite book right behind Cooking with Pooh, Yummy Tummy Cookie Cutter Treats. That book is Mathematical Statistics with Applications, 6th edition. Exercise 8.86 states a lot of words that might exceed my text-to-speech limit, so feel free to pause the video now to read the entire exercise. In short, we are looking at a sample of 20 light bulbs to find a 99% upper confidence interval for the standard deviation of the lengths of life of the bulbs. Then, we should find if the population standard deviation is less than 150 hours. First, we need to put the list into our calculator. Using the one-variable stats doohickey, we find that our sample standard deviation equals 186.693. Which is approximately equal to the number of times I've misspelled Chebyshev's theorem. Also, since we are using a confidence bound of 99%, our alpha equals 0.01. Using theorem 7.3, we know that the equation on screen has a chi-squared distribution with n-1 degrees of freedom. In this case, our sample size n is 20. Using my fancy TI-83 Plus that I stole from my roommate, I find that 20 minus 1 is in fact 19. Now that our setup is complete, we can finally start to calculate our confidence interval. We want to use the formula shown because we want to see what value that 99% of light bulb life lengths are below. Rearranging the first formula gives us the second, which gives us our upper confidence bound for sigma squared. We still don't know our chi-squared value for 0.01 at 19 degrees of freedom. I contemplated crying and giving up, but then I decided it would be better to cry and Google how to use my calculator. Just kidding, I knew how to use my calculator. Anyways, to find the value we're looking for, we should use the inverse chi-squared command. Our area is 0.01, and our degrees of freedom is 19. This returns a chi-squared value of 7.63273. Now, let's plug our numbers into our equation as fast as we plug in our phone when it's at 1% and we're expecting an email from our favorite professor. Our calculations show that our sigma squared is greater than or equal to approximately 86,762. Now, if you have a brain cell count higher than me, which is fairly easy considering it took me 15 minutes to figure out the problem, you'll realize that this is not in fact the standard deviation we were looking for. Let's take the square root of our answer, which gives us a standard deviation less than or equal to 294.554. Now, our goal is to find if the true population standard deviation is less than 150 hours. We want to find the chi-squared value at this standard deviation and find the area below it to find the significance. We should plug the population standard deviation into the formula we used earlier. Then, we go to the calculator again and use the chi-squared CDF command. Our upper bound is our chi-squared value, and our degrees of freedom are still 19. Using a level of significance of 0.05, we can conclude that there is not enough statistical evidence for the standard deviation to be less than 150 hours. However, since our p-value is so close to 0.05, our conclusion can change based on our level of significance. I'm 100% confident that the correctness of my answer is between correct and not correct. If you have any questions, feel free to send me an email, text message, Twitter or Instagram DM, written letter, or throw a brick through my window and ask me in person. Haha, just kidding, letters are so 2019. Make sure to include your credit card number and social security number for safekeeping, of course. Thanks for watching.